Welcome to 8.2, Arithmetic Sequences and Partial Sums. In a lot of regards, this is an easier section than 8.1 because what an arithmetic sequence is a sequence that goes up by a constant amount each term. So like 2, 5, 8, 11 is arithmetic, and we would say that the difference is 3. Or 10, 9, 8, 7 is arithmetic, and we would say the difference is -1. So some of the things that were challenging about 8.1 aren't going to be in this section. Now here's a formula that you will ultimately be tested on. This is a formula that should make total sense to us. I write it slightly different. You can write it the way they have it here. I write it slightly different. I put the plus D first. Obviously, algebraically, no difference at all. But here's how I interpret this. In this sequence here, we add 3, add 3, add 3. So we start at 2, and so 2 is our first term, and we start adding 3's. How many 3's do I need to add? Well, to get to our first, second, third, fourth term, if we started at 2, we only add 3 1, 2, 3 times. It's the number of steps from the first term to the final term. And the number of steps is the number of terms minus 1. 4 terms here, but just 3 steps to get there. So it's the first term plus the difference repeatedly. How many times? Well, how many steps does it take to get there? That's a really big issue this chapter. Okay, here's another formula that should make sense. It shouldn't be a memorize. This says the sum of the first n terms. And I'm going to write this one differently. I'm going to say it's a1 plus an divided by 2 times n. And the reason I do that, hopefully this is going to make sense to you. Let's say we've got, I'm going to come up with the simplest of arithmetic sequences, perhaps. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 and plus 11. If I was to ask you what the average term is and you didn't know, weren't alert to this, you may just add all these up and divide by 11. And that's the way we find an average. However, if it's arithmetic, excuse me, if it's arithmetic, we're going to go ahead. There's another way to do this. We could find the middle term. Just count in. 6 is the middle term. 6 is the average. But and that might not be convenient if there's 9,000 terms that we're dealing with, or it doesn't even work if there's an even number of terms. We'd have 2 middle numbers. But 6 is the average, but I can also get that here. 1 plus 11 divided by 2 is 6. Or 2 plus 10 divided by 2 is 6. Or 3 plus 9 divided by 2 is 6. Or 4 plus 8 divided by 2. We can get it a lot of ways. But if we know the first term and the last term, and it's arithmetic, we can add those together and divide by 2, and that gives us our average. And if we know our average, the average of all 11 terms is 6. Well, what do we know about average? Average equals total divided by the number of items. So the total of this sequence would equal, or any series, any partial sum, the total could be multiply across. We get the number of items times the average term. Okay, if that makes sense to you, this formula should make sense. To find a sum, if it's arithmetic, this doesn't work for all sequences. If it's arithmetic, we can take the first term plus the last term divided by 2. What is that? That's the average. And n is the number of terms. Okay, so those two formulas we need to focus on till they make sense for us. Let me know if I can help with that. All right, let's take a look at some applications of determine whether or not the sequence is arithmetic. Well, this sequence goes down 0.6, down 0.6, down 0.6, down 0.6. You can get that by taking 3.1 minus 3.7, 2.5 minus 3.1, 1.9 minus 2.5, etc. Therefore, this sequence is arithmetic, and the difference is negative 0.6. Number 10. This sequence goes up 1/3, but then it goes up 2/3, up 4/3, up 8/3. It's a pretty easy pattern to see, but it is not arithmetic. It doesn't go up by the same amount each time, and we are done. 11 through 20, write the first 5 terms of the sequence. Determine if it's arithmetic. So, A1 is 150 minus 7 times 1, 143. A2 is 150 minus 7 times 2. That's 150 minus 14, 136. A3 is 150 minus 7 times 3. 150 minus 21, 129. A4 is 150 minus 7 times 4. 150 minus 28, 122. And A5 is 150 minus 7 times 5, 150 minus 35, 115. Note, we go down 7. We go down 7. From 129 to 122, we go down 7. From 122 to 115, we go down 7. It is arithmetic, and the common difference is negative 7. May start to recognize if we have a linear equation here, just plus or minus something times n, and no other n's in there, no squares, it's going to be arithmetic. But that's not a two-way street. This is clearly not linear. Let's take a look what happens. A1 becomes negative 1 to the 2 times 1 plus 1 to the third, negative 1. A2 is negative 1 to the, put 2 in here, and we get 4 plus 1, 5. And that's negative 1. A3 is negative 1 to the 6 plus 1, 7th, negative 1. A4, negative 1 to the 8 plus 1, 9, negative 1. And A5, I'll bet you can guess, 10 plus 1, 11, and that's negative 1. So is this arithmetic? It is. It goes up by 0, up by 0, up by 0. So it is arithmetic, and the difference is 0. All right. Let's move along here. Write the first 5 terms of the arithmetic sequence. Now they're telling us it's arithmetic to begin with. Oh, they give us the first term 5, and they tell us the difference is negative 3/4. So I'm going to go 5, and I'm actually, because it's in fourths, the difference, I'm down below that. I'm going to write 5 as 20 on 4. And we reduce by 3/4, 17/4, reduce by 3/4, 14/4, reduce by 3/4, 11/4, and reduce by 3/4, 8/4. So my terms are 5, 17/4, 7/2, 11/4, and 2. There's our solutions. Okay, write the first 5 terms. Well, I don't have the difference. It's really easy when I have the difference. What I do know is the 5th term is 16. I just need to build backwards from 16, but I need to know the difference. Okay. On the way to this 38.5, somewhere I hit 16. And then later on, I'm going to get to 38.5 down the road. So eventually, I'll get to 38.5, and I can just start from 16. So that equals 16 plus. How much do I add each time? That's what we're after. How many times do I add it? Well, I need to get from the 5th term to the 14 terms. The number of steps from the 5th to the 14th is 14 minus 5. We're going to talk a lot about that in class. The number of terms from here to here, from 5th to 14th, is actually one more than the number of steps. But steps from 5 to 14 is 14 minus 5, 9. So our difference is equal to, it was 38.5. I would need to subtract 16, and then I still have to get rid of this 9 with division. So let's take a look at that. Grab my calculator here. We've got 38.5 minus 16 divided by 9. And I get 2.5. So D is 2.5, which means I'm going up 2.5 each step that way, but back this way I'm going to go down 2.5. 13.5, 11, down 2.5 gets me to 8.5, down 2.5 gets me to 6. Not too bad. Nothing magical about this formula that says we have to start with A1. In this case, I started with A5 and built to A14. We just have to be able to recognize the number of steps. All right. Write the first 5 terms of the arithmetic sequence. They're telling us it's arithmetic. And they're telling us that the first term is 6. And they're telling us that each term, well, I'm going to do this one this way. If we know a term, we can add 5 to it, and that will give us the next term. It's that easy. If I know a term, the kth term, if I add 5 to it, I get the k plus first term. Or if I know the 12th term, add 5 to it, I get the 13th term. So I just need to add 5 to this. I get 11, I get 16, I get 21, I get 26. Find the common difference and write the nth term of the sequence. So our common difference is positive 5. Well, of course, I'm adding 5 to each term to get the next term. So the nth term equals, we got to start somewhere, starting at 6, continually adding 5 to each term. How many steps to get to the nth term? N minus 1. How many times do I have to add 5 to get to the 4th term here? 1, 2, 3 times, 3 steps. It's n minus 1. Okay, this says if I know a term, to get to the next term, just subtract 2.5. So minus 2.5, negative 1, minus 2.5. Minus 2.5 gets me to negative 6, minus 2.5, negative 8.5. The common difference is, of course, negative 2.5. We're going down. To find the nth term, we start at 1.5. We start subtracting 2.5s. How many times? N minus 1. The number of steps to the nth term. All right, 43 to 46. Find the first 2 terms of the arithmetic sequence, or excuse me, the first 2 are given. Find the missing term. Well, if they give me the first two terms, the difference is the second term minus the first term is 10. And if I've got that, I can just say the 9th term equals start at 3, start adding 10s, how many of them, how many steps to the 9th term from the first term? 9 minus 1, 8. And we get 83. Note, you could also do this. A9 equals 13 plus. Start with A2. I'm still adding 10, but how many steps from the second term to the 9th term? 9 minus 2, 7. We still get 83. Okay, 46. I've got the first term, I've got the second term, so the difference, negative 13.8 minus negative 0.7, that becomes negative 13.1. There's the difference. How do I get to the eighth term? I have to start somewhere. Negative 0.7. What am I doing? Subtracting 13.1. How many times do I need to subtract it? Well, how many steps is it from the first term to the eighth term? Takes 7 steps, 8 minus 1. So we get, just being lazy here, we get negative 0.7 minus 13.1 times 7. Negative 92.4. Okay, find the sum of the finite arithmetic sequence. Well, it'd be easy to do this just like we would normally add. But we notice we go up 3, up 3, up 3. It is arithmetic. And the sum of, how many terms do we have? 1, 2, 3, 4, 5, 6, 7. The sum of those 7 terms is the average term. The average term could be found by taking 1 plus 19 and divide by 2. Times, how many terms do we have? 7. 20 on 2, 10. Times 7, 70. Find the sum of the first 50 negative integers. The sum of the first 50 negative integers would look like this. Negative 1 plus negative 2 plus negative 3 plus dot, dot, dot plus negative 50. This is most definitely arithmetic. Down 1, down 1, down 1. How many terms are there? Well, this is term number 1, term number 2, term number 3, term number 50. We're trying to find the sum of those 50 terms. The average term is negative 1 plus negative 50 on 2. That would get us right into the middle of our terms. Take that times the number of terms, and once again we have it. So let's see, negative, that would be 51 divided by 2 times 50, 1275. Negative 1275. This one people will miss. Got to be careful. You'll see why, I believe. So this would be negative 10 plus negative 9 plus negative 8 plus dot, dot, dot plus 49 plus 50. And definitely arithmetic. Common difference is 1. The average term, so sum of some number of terms equals negative 10 plus 50 on 2. But how many terms are we dealing with here? I would think some people might say 60, maybe 61, 62, 59, somewhere around in there. Well, steps is easy to find. The number of steps is 50 minus negative 10. Because this, or, I mean, we could call this term 1, but since we're counting by ones, we have a unique opportunity to say, how do I get from negative 10 to 50? So the number of steps is 60. The number of terms then is 61. And I think here's what happened. If you go to 0, we'll have negative 1 plus 1. You can tell we have 10 terms right from negative 1 to 10. We have 50 here, and then we have 0 as another term. Causes people problems. So let's see, what do we have? 40, negative 10 plus 50, 40, divided by 2 times 61. Could have done that one in my head. 1220. And it's the sum of the first 61 terms. We got to be careful with that. Okay, a few more problems here. Find the indicated nth partial sum means I want to find the sum of the first 25 of these. Well, to find the sum of the first 25 of these, an equals, we started at 2, and we start adding on, let's see, plus 6, plus 6, plus 6. We add on 6 how many times? Well, how many steps from the first term, how many steps from term 1 to term 25 would there be? 25 minus 1, 24. And that's it. And that is 144 and 2, I believe, but we'll check it. 2 plus 6 times 24. Yep, 146. Find the sum of these first, or not the sum, we're finding the 100th term. Oh, we're to find the sum. You know what? I just found the last term, and I wish I would have, I actually need the last term. I'm sorry, they're asking for the sum. So we need S25. Well, that equals first term, 2, plus last term. So even though I was just trying to find the 25th term, I actually need it. It's first term 2 plus the 146 on 2 times the 25. The average term, first plus last, divided by 2 times the number of terms. So let's see, that's 148 divided by 2 times 25. 1850. Okay. In this case, actually easier. This is when I recognize, hey, this is an easier problem. I didn't do the last one right. We've got the first term. We got the 100th term. We want S100. Well, that's term 1 plus term 100 divided by 2, the average, times the number of terms, 100. How easy. We've got 322 divided by 2 times 100. And I've got 16100. Okay. Find the partial sum without using graphing calculator. Well, let's take a look at what our terms look like. When n equals 1, I get 2. Plus, when n equals 2, I get 4. Plus, when n equals 3, I get 6. I see our pattern. Plus, dot, dot, dot. When n equals 100, I get 200. So the sum of some number of terms is going to equal 2 plus 200 divided by 2, the average term. How many terms? Well, how many steps is it from 1 to 100? There's 99 steps, therefore 100 terms. I'm finding S100. Pretty clear when they go 1 to 100, but if this was 7 to 106, I'm not so sure that's as clear. So times 100. So we get, this one I could definitely do in my head, but we'll go ahead. 202 divided by 2 times 100. Nice friendly numbers. 10/100. Not point. Okay. All right. So we're going to find two different summations and subtract those. Let's go sum as n equals 51 to 100. That is 51 plus 52 plus 53 plus dot, dot, dot plus 100. This is just plain old n here. So that is the sum of how many steps from 51 to 100, 49, how many terms, 50. So that's S50 here is first term 51 plus last term 100 on 2, there's our average of that list, times the 50. 151 divided by 2 times 50, 3775. And now we're going to find n equals 1 to 50. That's 1 plus 2 plus 3 plus dot, dot, dot plus 50. That's 50 terms, 49 steps, 50 terms. That's 1 plus 50 on 2, the average term, times 50. So 51 divided by 2 times 50. 1275. If we subtract those, 75s cancel. 37 minus 12, we get 0, 0. 37 minus 12, 2500. Not too bad. And use a graphing calculator to find this. Okay, I'm going to show this two ways. The easy way on the CE, Love this thing. I can go to alpha window and I get summation. There's other ways to find that, but that's pretty convenient. And now I can just straight enter it as it is. So I've got x equals, just cursor around over here. I get 0, cursor up to 100, cursor over. I'm going to enter a fraction here, alpha y equals, and I'm going to go 4 minus n, or 4 minus x, as the case may be, on 4. And I'm going to enter. And it takes a little bit of time to think through that. And we get negative 2323 on 2. And you can list that as a decimal if you'd like. Okay, if you do not have that, here's what we would need to do on, this is an 84 plus that does not have that feature. I need to get to here. I need the sum of the sequence. The sequence is 4 minus n divided by 4. I need the sum of that sequence. Whoops, don't want that parenthesis there. As x runs from 0 to 100. I need to get all of that entered. Okay, here we go. It's a mess, I'm sorry. I'm going to go to second catalog, which is second 0. I want to go down to the S's for sum, but since sum's near the end of the S's alphabetically, I'm going to go down to T's. Notice we're in alphabetic here. Go down to T, that's T alphabetic 4, gets me down to tangent. Back up 1, sum. Now I want to go to sequence, second catalog. I want to go down to the S's here. So S, no, I'm jumping around a lot here. So S jumps me down into the sample test. I'm going to bump down here. There's sequence. Now I get to enter the formula. Numerator, 4 minus n, or x. Close those parentheses. Divide that by 4. Comma, right above the 7. Comma, as x, comma, goes from, let's see, 0, comma, to 100. And I get negative 1161.5. If I multiply that by 2 just for checking purposes, there's my negative 2323. So that way we would get negative 1161.5, which is equivalent to that. Okay, here is the assignment from there. Some of these are going to be quick, some are going to take some thought. I think 8.1 or 8.2 should be a little bit quicker homework set than 8.1. It's a little bit more specific. It's all kind of tied into the same 2 formulas. Let me know if I can help. And as always, ask questions.